Hello, my name is Jonathan Lewis, and today I'll be presenting my CSE 572 course project proposal. For our course project, we want to enter a Kaggle competition, and the competition we chose was the Open AI Data Visions Pillar Spring 2025-20 Challenge. Here are group members, and I hope you enjoy today's presentation. So, some background. So, the Kaggle Open AI Data Visualization Competition is it is to build a fine-tuned model to classify sports video games images into multiple distinct categories. This is at its base an image classification problem, and the categories are provided to us. The categories that are provided are basketball, volleyball, tennis, soccer, and American football. Now, these images come from the dataset Sports 10. There's 1,129 images within here, all taken from different sports video games. They're all taken at screenshots, which have different resolutions and sizes and different art styles. This project's reference to data mining is it does require a full end-to-end pipelining. We are going to need to do some light pre-processing on the data. We will need to do feature extraction, classification, and evaluation. So, why does this matter? Image classification is, at its heart, a very important method. It can be used within different applications outside of just this. It can be used for security. It could be used for monitoring for different activities. Here, one of the main ideas that we ran into was we'd be able to use this software that we're creating to extend in different gaming platforms or sports broadcasts, and as written here, even some security or monitoring applications where recognizing specific activities is important. One issue that we'll run it, or that I'll explain later, but it's something that we thought would be helpful here is helping advance robust models with limited data sets. Because we're using a limited data set, it's hard to build a model that is robust and can stand up and will not fall to issues such as overfitting. Now, this could be helpful in automation in sports and esports. So, automatically tagging of gaming content for things like YouTube or Twitch. It can also be used for personalized recommendations for people when they're noticing they're watching a certain thing. They can start recommending similar thing, as well as content moderation. This project also just provides a good benchmark for multi-class image classification. So what are some of the challenges that we will face within this project? One of the big glaring images that we're noticing currently is that it will be within data. The data comes from a lot of different video games. As you can see here, these are two images I pulled from the dataset, and they are vastly different art styles, but they both convey tennis. Because they're also game screenshots, a lot of the images come in different sizes and resolutions, which will make it difficult for the model to be able to distinguish, or we'll have to do pre-processing to help normalize these before we can feed it to the model, and then the model might have trouble differentiating them because of the different art styles in the game. Another issue is data scarcity. So I mentioned earlier that the Sports 10 dataset only had about 1,129 images in it. That if everything is evenly split, that cuts down to about 226 images per class, which could cause potential overfitting if we do not build our model correctly. We are also worried about a potential data bias, where if one of the sports has a bias within it where more of the images are from one sport rather than the others, it can skew our results as well and cause issues within our classification. Some of the essential tasks that we need to take on for this is, first of all, our main task is going to be a supervised multi-class image classification. This is because we are provided all the categories and we're just worried about making sure that each of the images meets that classification. Data processing. So as I mentioned, we will be doing some light data processing. Most of this is data normalization within the size of the images, because they are all screenshots and come in a wide variety of shapes and sizes. As of data collection, for this competition, we do not need to collect more data. As per the competition guidelines, we need to use the current data set provided to us. Now, data should be ready to feed into the pipeline after some light pre-processing. As mentioned, most of it's normalizing the size and making sure that we find a good size within that won't have us lose too much information from the smaller resolutions or the bigger resolutions. So this is a rough pipeline that we're planning on using. We'll start with the raw images. We'll do our exploratory data. This will be just kind of figuring out different distributions of the data and then seeing what we have to work with. We'll go into data processing. This will be a lot of our normalization. This is just a rough estimate of what we might work with in terms of sizing. We'll be resizing our images. And then we'll be doing data augmentation as well, just to help with overfitting. Next, we'll go into our feature extracting and modeling. We are planning on training a CNN model to recognize these images, and we're going to see if we can fine tune our model to work with this data set. Otherwise, we might need to work with a pre-trained CNN model. Next, we'll do our standard model evaluation to make sure the accuracy of our model as well and see what we can adjust to fine tune it. And finally, it'd be ready for predictions and deployment. So that is roughly what we are planning for this this class project. If you have any questions, feel free to reach out to any of us in the team. We will be happy to answer. Thank you for your time.